Good morning everyone. Today in this session I will explain the heat of combustions of some examples. Let us see. So here in this given question, which has highest heat of combustion. So we know already heat of combustion, that is directly proportional to number of carbon atoms. So heat of combustions directly proportional to number of carbon atoms. We already discussed it in the previous class. Okay, so that is case 1. In the case 2 already we know that heat of combustion, that is inversely proportional to stability of alkene or alkyne if there is some number of carbon atoms same. And what about it in the alkanes? There is in the alkanes heat of combustion inversely proportional to number of CH2 bonds. Okay, if there is a number of carbon atoms, there is maybe the same, then we have to check the CH2 bonds, which is consists less CH2, that's to release the heat energy excess by the combustion. Okay, right, let us see. So in the given first question, there is a option A, B, C, D, then you follow the A, B, C, D in that. So first you have to count the number of carbon atoms, so that is the base point of heat of combustion. In the given question, there is a first 1, 2, 3, 4 carbons are there here. Now in this question there is a 4 carbons also there, here is also 4 carbons, but in this D there is a 6 carbon atoms there. So obviously the base point what is there, heat of combustion, number of carbon atoms, both are directly proportional. So obviously 6 carbon which has, that is the excess of heat of combustion. So to heat of combustion the option is D. Then come to the 4 carbons of that A and B and C. So in that we have to check the stability order. Okay, so obviously we know that there is a stability, the first one is getting high because there is resonance is excess, there is the resonance is present, but here there is no resonance because there is no conjugation, that's why there is a no resonance. So in this two option, resonance is not present. For this two option there is no resonance, so obviously this is more stable. So I will give the stability order for the 3 options. A is more stable due to the resonance. And come to the B and C, option B and C. Option B and C, there is the unsymmetric and symmetric. So we know already unsymmetric is the more stable than the symmetric. So obviously the B is more stable than C. So B is the unsymmetric and C is the symmetric. B is unsymmetric, C is the symmetric. So obviously the stability order for these 3 A, B, C. So what about heat of combustion? So that is to reverse, B, C, B, A, C, B, A. So we have to mention that C after D, C, then after B, then after A. Sir, you have to tell me the in that A, B, C, D generally which is more stable. Okay, see here we know that already resonance is more priority than the hyperconjugation, then inductive effect. Okay, so here is the resonance energy is there, but in these 3 options there is no resonance. But in these 3 we have to check the alpha hydrogens. We know already that is the concept of heat hyperconjugation. But what about the resonance energy? What about the resonance? Resonance is means there is the conjugations. If maybe the conjugations is more, that getting the more stability. Okay, then in the priority order we know that already resonance is first priority than the hyperconjugation. So as per the stability order in that A, B, C, D, so generally the stability is A is more stable, then D, then B, then C. Okay, understood? So but here is what happened, A is first is more stable because of resonance. Then after D means there is the alpha hydrogens 6 from this side 6 and from this side 6, 3, 3, 3, 3, 12 alpha hydrogens. But in this case 3, 3, 6, 3, 3, 6. So obviously which has highest alpha hydrogen, that is alkene is more stable. So finally the D is the more stable than the B and then the C. What about in the B and C? There is 6 alpha hydrogen there na, 6 alpha hydrogens, here is also 6 alpha hydrogens, but here in the 12 alpha hydrogens. So obviously D, then after D, because this is unsymmetric form, this is symmetric. Okay, so why it is to first? Because here in this question there is a resonance is appeared, so that's why the A is the more stable. So finally the A is the more stable. Okay, but not it is the first in the heat of combustion of that C option. Okay, because there is in the D, how many carbons there? 6 carbons, but in the C option how many carbons are there? 4 carbons. So don't follow that from that stability order, which is to inversely proportional to heat of combustions. So first the base point is the, we have to check the number of carbon atoms, whatever it is, maybe it is to has the number of carbon atom excess, then automatically heat of combustion also excess. Okay, right. Next let us see the second question. So how many carbons present in this question? So 6, 7, 8. So obviously the each of option consists the 8 carbon atoms. So there is no number of carbon atoms same. So then what we have to check? So there is a given double bond. Okay, so we have to go for the stability. So heat of combustion inversely proportional to STB. So which has same number of carbons. So of that alkene, then heat of combustion, stability, both are opposite. So obviously there is now here is the alpha hydrogens. How many is there? This is alpha, this is alpha. So totally there are 6 alpha hydrogen here and 2 here and 2 here. Totally how many is there? 10 alpha hydrogens. Very nice. And what about this is alpha? For that alpha, here is also alpha, this is also alpha with respect to the double bond. 2, 3 and 3, 6 alpha hydrogens. And what about here? There is a CH2 bond here and double bond with respect. This is, here is a carbon and 2 hydrogens are there. It is the alpha carbon and this is also alpha carbon. Now here is a one alpha hydrogen present. So how many hydrogens are there here? 3 alpha hydrogens. So obviously the stability go for the of that second option. Stability is which is highest? First, very good. Then second, then third. Very nice. So what about the heat of combustion? So heat of combustion there is opposite. So inversely proportional. So the third is first, then second, then first. So come to the answer 3, 2, 1. Okay, understood? Very nice. Right, very good. In the third question, which has highest heat of combustion? Obviously, here is 6 carbons, 7. So from first component to last component, there is the carbon atoms are increases. That is the main important for the combustion. Okay, the last one is having the highest heat of combustion. Okay. In the fourth question, so how many carbon here? 3 and this side 3, total carbon 6, and now here is a 5 carbon. How many is there? Okay, 2, 2, 4 and 5. Very nice. 5 carbons. There is the 4 carbons. So obviously which is highest will give the heat of combustion? The first one is the highest due to the number of carbons increases. Let us see, come to the second question. There is a 4 carbons and here is also 4 carbons, but there is a depend on the stability of that question. So heat of combustion inversely proportional to STB. So then go for the, here is with triple bond, this is alpha carbon, this is alpha carbon and this is alpha carbon. There is a 2 alpha hydrogen present and there is a 6 alpha hydrogen present. So obviously the stability go for the STB. The first is greater than second. And what about heat of combustion? Heat of combustion is reverse, 2 greater than 1. Okay. So what about the sixth question? Sixth question, don't make the mistake. So everyone maybe to give the answer, the first is highest, then the second. But this is the question is different. So you know that already carbons is increases, automatically you say that the first answer is the first is excess heat of combustion will be give. But what is the given the question in the heat of combustion per mole CH2? There is a different way of question is given. So when it is to cyclohexane on burning on the in the presence of oxygen, they will be to give the 600 kilocalorie per mole. After on burning, cyclohexane given 600 kilocalorie per mole. After on burning, this cyclopropane is given 350 kilocalorie per mole. So finally, this is the excess. We know that. Yes or no? Heat of combustion. This is the excess. So in that from that value, we give the answer. The first is the mole. But what is the question there here? Heat of combustion per mole. So now you have to check the how many CH2 bonds are there here. Here is a CH2 is that is equal to 6, but here is the CH2 is that is equal to 3. So finally we count the CH2 number of, there is a CH2 6, there is a CH2 3. So in that question they also to give asking the question per mole CH2 heat of combustion. इसका मतलब एक CH2 कितना हीट ऑफ कंबशन देता है, मतलब हीट रिलीज पर CH2 कितना है वो क्वेश्चन है. हम ऐसा देख के क्या करते इसको ऑप्शन करके आए थे, ऐसा नो, बट हियर वी कैलकुलेट द पर मोल CH2. सो per mole CH2 that means 600 upon 6 CH2. At the same time इधर per mole कितना है 350 upon 3. 3 is means number of CH2. So 100 is the, so it's come the 116 something value. So finally per CH2 that will be give the, matlab there is one CH2 will give 100 kilocalorie per mole. Now in this case per CH2 that will be to give the 116 kilocalorie per mole. So what about the answer is correct? Very good. The second is first, then first. Option second is the first, due to that will be given excess amount 116, but the first one is given 100 kilocalorie per mole. I hope you understand. So I will next in the class I will explain the different topic. Okay, right, no doubt.